The Sun is a massive, luminous celestial body that lies at the center of our solar system. It is a star, primarily composed of hydrogen and helium, and serves as the primary source of light, heat, and energy for the planets orbiting around it, including Earth. Today, we will find the reason why the Sun's atmosphere is hotter than the surface. Before we start, please show your support by subscribing if you haven't already, and ring the bell so you don't miss any of our interesting videos in the future. Now, let's get started with today's content. The corona, at the outermost part of the Sun's atmosphere, is thousands of times hotter than the star's surface, possibly due to weak but steady spreading waves that help transfer energy. The surface of the Sun is the photosphere with a temperature of about 5,500 degrees Celsius. However, even farther from the core, the outermost layer of the Sun's atmosphere, called the corona, is much hotter, often reaching temperatures of up to 40 million degrees Celsius, according to NASA. The corona is made of hot ionized gas called plasma, and is also where extreme space weather events, such as solar flares, originate. But before, researchers still weren't sure why the corona was so hot. In the study published in detail on September 12 in the journal Nature Communications, scientists study a common oscillation associated with the Sun called low-amplitude, non-decaying torsional oscillation. This is a fluctuation in the coronal magnetic arc, a dome-shaped structure made of plasma that begins in the photosphere and extends into the corona. These waves are relatively weak, but have not weakened in strength over many cycles of fluctuations. Therefore, they can provide large amounts of energy to the corona over time. The team focused on how the wave spreads up and down, left and right, or at any angle, a characteristic called polarization. The ability to analyze the 3D geometric characteristics of waves can reveal their origin and available energy. However, previously scientists lacked a method to examine the wave ring from multiple viewing angles, thereby detecting polarization. Valery Nakyryakov, a solar physicist at the University of Warwick in Coventry, UK, and colleagues used data from the European Space Agency's ESA Solar Orbiter and NASA Solar Dynamics Observatory to analyze the ring corona from multiple locations. They found that nearly every wave vibrated in the same direction. The discovery shows that energy from the Sun's surface can reach the corona and heat it. According to Nakyryakov, the research results provide important information to answer the persistent question of what heats the Sun's corona. And that's the end of today's episode. If you find it interesting, please give me a like and subscribe to the channel. Thank you, and see you again.